I guess. So now let us look at the a problem called n queens. So n queens is a classical backtracking problem. So in n queens we have to place n number of queens in a chessboard of size n cross n. So there are some limitations that we can only place a queen in only one row. I mean we can only place a queen here, here. When and it should be placed as such. No two queens are under attack. That means a queen can move in the column direction, in a row direction, and also in a diagonal direction. So we have to place all the four queens in such a way that no two of them are under attack. So let us solve this using a simple methodology. So let us take. So let us assume that there are four queens, right? So why don't we just label these things, okay? So let's label them. So this is the row 1. So this is a row 2, row 3, and row 4. And this would be a column 1, column 2, column 3, and column 4. So we have the following constraint that in each row there must be one queen at least placed in at least one row. Since it's not possible, right? If there are a tweak, two queens in the same row, then they will be under the row attack, right? So they cannot be placed. So there has to be one queen in each row and a one queen in each column. So these are the constraints, and no queen shall be under attack. So now let us look how can we place them. So what are the possible combinations? So the first queen, which is red here. So let us place the first queen here in this way. So if there is a first queen here, so we can place the second queen. So we how can we place it here? Can we place it? No, because it will be under this attack, right? It will attack. So how can it be placed here? No, because it is under the diagonal attack. So there are two possible places. It could be placed here or here. So let's assume let's assume we are placing the queen in this position. Okay, if so the second queen is also placed. So now let us go for the third queen. So where can we place the third queen? So can we place it here? No, because it is under attack of this red first queen. Can we place it here? No, it is it is under the diagonal attack of this green queen. Okay, so it is under the direct attack, so it is also attacking here. So there is no way you can place the queen number 3 in this row number 3. So we have to backtrack to the a previous queen and ask the queen to change its position. So we will be first backtracking to this queen and we'll be placing that queen in the next possible position, like here. So if it is placed here, so now let us look at the third queen situation. So we cannot still place it here because it is under attack. We can place it here and we cannot place it here or here. So we got a possibility that we can place it here. So now let's just put the queen 3 here. Okay, so now let's go for the queen number 4. So queen number 4. So can we place the queen 4 here? No, it is under attack. Can here? No, it is under attack. Here? No, it's under the diagonal attack of the queen 3. So can we place here? No, it is under the column attack of the fourth queen. So there is no possibility for the fourth queen to be placed here. So we have to backtrack. So what if you when we are backtracking to this queen, so we're removing its position. So can we place it here? No, it is under the diagonal attack. Can we place it here? No, it is under the column attack. So there is no way we can place a queen here. So we have to change the position of this one too. So there is no other places. So it means that placing the first queen here is not a great move. So we have to choose another. So we can represent this in a form of tree. Okay, let's say we place so from the starting point there are four possible ways. You can place it in the first row first column. You can place it in the first row second column. You can either place it in the first row third column. You can place it in the first row fourth column. So this is the fourth possibility. So now we are exploring the possibilities of a place. If we place our queen in the first column here, so we have explored the possibilities. So we got some possibilities, but they are also expanded, but somehow we didn't get to the final answer, which is placing all four queens. So this path has been rejected. So now we'll go to this path. So what if we do what if we place a second queen here? So now let's check the possibilities of placing the second queen. Can we place it here? No, it will be under the diagonal attack. It is under the column attack. It is under the diagonal attack. So we can place it here. Yeah, so this is fine. Now what happens for the third queen? So can we place it here? Yeah, it's fine. It's not under any kind of attack, so we can place it here. So what about the fourth queen? So what about fourth queen? So can we place our fourth queen here? No, it is under the column attack. Here, no, it is under the column attack. Here, no, it is under the column attack. But here we can see that this place is not it is not at all a problematic place. So we can place it here. So if we observe that we have placed all of our queens in a four different rows and a four different columns without them attacking each other. So this is one of the solution for the n queens problem. There might be some other solutions which do look similar to this. So how do we write a C++ code for this thing? So how can you write a code? So now let's just define an array. Okay, so let us include this thing. Okay, so see we have since we have a chessboard, we have to define a vector of vectors, which or you can just say an array, a two-dimensional array. So I'll be taking a two-dimensional array. Okay, so we have to know the dimensions. Let it be an n dimension, and take the value from the user scene, and then we have to create a 2D array. So there are many ways of creating 2D array. I will use a dynamic memory allocation technique. So there will be int star. Okay, there will be an int star arr, and arr will be a new integer pointer array. Okay, so this is an integer pointer, an array of size n. So there will be an integers. So if we can also visualize this thing, how integer array is created. Okay, so there is an arr. So there will be an array arr. So this will be a two-dimensional array. So this will contain address of n integer pointers, which is what is n integer pointers, right? N integer pointers, and they themselves can contain elements, right? So let us define int I equals to 0. Sorry, written twice. I equals to 0, I less than n, and I plus plus. So arr of I. So for each ith element I have to create another new memory, and this new memory will be of integer type. Okay, and there's another thing that we have to initialize each of them to 0, because we don't want it to contain any garbage value. So we'll just take another for loop for int j equals to 0. So j will iterate through the array and make every element to 0. So we have to deal with this array, right? New int arr of I. So it will make arr of I is an array and j is its element, and I'm keeping them as 0. So this will create our array. So we can visualize this thing, but we'll do that later. So let's now just focus on the code. Okay, so what happens is now uh, we'll call a function. We'll call the nqueens function, right? Okay, so now let's define a function nqueens. So it shall return a boolean value. Okay, So where we'll be passing the array. We'll be passing the array A, and we'll be passing the rows and columns. Let the rows be X and the columns. Actually, we don't have to pass the columns because the queens are supposed to be placed row wise. So we're only interested in about the rows. So we'll only be passing rows and this size m. Okay. So this is going to be our function prototype. In the function, what we're going to do, we're going to check if, see, x is the number of rows, right? I mean, x already uh, points to which row we want to place the queen. See, if there's a case like, okay, we have placed all the queens, so now we're looking for the fifth row because the row value will increment. So if it is pointing to a row which is greater than the n itself, then we have to stop the execution of this program. So that is going to be our base case, which is if x x is greater than or equal to n, and then we have to stop the program and we have to say that return true, because can, so all are, so is it true that all the queens are placed? Yes, it's true. So we will be returning the value true. Okay, and this is the case. So if it is not the case, that means we might be here, 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 or here. In all these four cases, we have to choose a column such that it is not contradicting. Okay, so we have to choose a column. So let us just rewrite this thing. We'll just yeah, we'll trace it back. Okay, so what we'll be doing is we'll be running a for loop, which is int col equals to 0 and col less than n and col plus plus. Okay, for each of this thing we will check if it is safe. So we'll define the function life. So we'll define the function later. We'll we'll see if is it safe to put, is it safe to put in the array A of row x and column col, right? The row x and column col and size n, is it a safe to place here? So we're asking, right, in a second row for the first column or the second column or the third column or fourth column, is there any a place where it is a safe to place? So let us look at the first way. Okay, so if we are considering this from the starting, the value of the column will be 0 and the row is also 0. So in that case, we think if a 0 and, sorry, I mean the a 0 and a 0 is it a safe to be placed? So it is obviously safe, right? So if it is safe, so what you want to do, you're going to make the a of x row and column of call to be 1. That means we have placed our queen there. So that is what we're doing. And since we have already placed the queen there, we have to check if placing the next queen is also a possibility. So we'll be calling the same function, which is n queens, right? N queens. So we'll be passing the same array, but we are extending the row. So the row will be x plus 1. And for the same column, no, we don't have to define the column for this one, right? So we'll just pass in the value n. So it will internally check for each column. So okay, so if this one becomes true, so what if this becomes true? So n queens is also returning true. That means all the places are queen, so this will also return true. So this will also return true to say, yeah. If it is not returning true, that means at some other point we have encountered a situation where it is conflicting with the other cases. So that returns a false value. That means n queens is not a placeable. Okay, so in that case we have to revert our a point, which is we have placed it here. So we're assuming that we have already placed, so we have to rewrite this thing. So we'll make it a 0 because no, it's not, so it is not a safe to place it here. So we'll not be placing, and after coming back from the for loop, that means for no column in the range 0 to n, there is no such column for that a given row X, such that we can place the queen safely. So in that case, we'll be returning the value false. So it's a false case, right? Okay, so this is about the n queens thing. So now we have to define the boolean is safe function. Okay, so is safe. So is safe will take in the arguments the int star star a and int x, which is the row, and int y. So let us keep the column value to be y for our use, and then int n. So these are our parameters. Okay, so in what way we can check if it is safe or not, right? So we'll check for if it is already having, okay, if the row is a, if this column, in this column, so let us assume that we are at the row 2. So we have to check for is there any column that is already filled. Okay, for the row 2, for row 2 a column 1 is already filled, or the column 2 is filled, or 3 is filled, or 4 is filled. So we have to check for int row, or int row equals to 0 from row 0 to row less than the the row less than the row which you are currently at, and row plus plus. In this way we're defining. So why is there a d here? Okay, so this is fine now. So what we'll check if the a of row, a current row value, and a column y, if it is not equals to 1 in any of the above vectors, then it's kind of a true. Okay, so then we have to return false. If it becomes true, that means there is already a queen placed in that column, so we just cannot place in that column. So we're just checking the this constraint, like, okay, so from row 0 to this, in this particular column, is it already placed or not. So we're checking that. And after this, we had, yeah, so after this, so let us assume that we are in this place. So what are the possible attacks that we might get? Okay, so we might get an attack from this side, or from the column, or from this side. There's no chance to get in this side, because we're only selecting this row as it is not placed already, and as the of 4 is not at all, in the placing order. So we just have to ignore these options. So we have to check if this and this and this is not conflicting. So we have already checked this thing, because for this column y, okay, this is the y. So for this column y, from row 0 1 till the row x, so this is the x, right? So till the row x, in that column y, I'm seeing if there is anything placed here or here beforehand. If it is not placed, then we'll just if it is placed, then we have to return false. If not, then we'll be return false. So now let us examine about this cell. So how can we examine this cell? So if this is the x and this is the y, then this cell is nothing but x minus 1, and this will be y minus 1, and even this cell is also attacking diagonally, right? So what would this cell be? This will be x minus 2, this will be y minus 2, right? So this is how I'm doing it. So we don't have to explicitly do that, we can just run it a loop. So what we'll be doing is, so we know that the row value, right, the int row, so the row value would be x, and the column value would be y, as in our case. So we see that this is the xth row and yth column. So this is where we have, so this is where we want to put our queen. So here we're gonna run a loop. What am I gonna do is, while there's a condition, see, uh, since we're looping back, we don't have to go beyond this plate, right? So this is our last one. So how to recognize this is our last? While row should be a greater than or equals to 0, and the uh, column should also be a less than, sorry, a greater than or equal to 0. So this is our condition. So we'll check if row is greater than or equals to 0 and the column is greater than or equals to 0. If it's true, that means we're still in the border itself. And we'll check if for any a of row and column is equals to 1. That means if it is already placed, we're checking for any row column. So for this x and y, is any row column if it is already placed. So this will check. If it is already placed, then this is not a good thing for us. So we have to return false. And after returning false, no, if it is not the thing, then you have to decrement this value, right? So what we did here, we did x minus 1 and a y minus 1 simultaneously. So we have to say row minus minus and column minus minus at the same time. So this will run for, so this loop will check if it is under attack because of this queen, or it is under attack of this queen. So these two cases will be it will be checked through this loop. And what is the next thing we have to do? So we have to check if there is an attack from this side. So how do we check if there is a queen placed here in this direction all the way? So if you observe, this is x, here it is x minus 1, so we're going a row back. But see what happens with y. So y becomes y plus 1. So the value of the column is getting incremented and the value of the row is getting decremented. So it is very much similar to what we have written here. We have to just change one statement. We don't have to write int again. So there is only one change, that the column becomes column plus plus. The column value all increments, and we'll check for each row and column if it is conflicting. So if it is not conflicting, so we have already checked all these three cases. If it is conflicting, this negative diagonal wise, the column wise, the positive diagonal wise, if there is no such problem, then we can say we can place our queen here. So we can say, is it safe? Yes. So at last we can return the value. If all of this is not returning any value false, then we can say true. It is safe to be placed here. So we'll be placing, so return true. And so since this is all we have, since we have our answer vector A, we have to print it. So for printing, I'll be taking, actually before printing we have to check if the n queens are placed or not. Okay, if n queens are placed, I have to first give it A, and then the row, from which row we want to start. We want to start from the 0th row, and we want to go till n. So if this is returning false, that means there is all queens are perfectly placed. So we just have to print it using int I equals to 0, I less than n, I plus plus. For j equals to 0, j less than n, j plus plus. And we have to see out the value ar, a of, sorry, it's arr, right? Okay, this is actually arr. So you have to see out arr of I comma j, so whatever the value there is, and some space. Okay, and after every jth iteration we have to move to the next vector. So we have to see out endl, have to do the endl. Yeah, so this is the code for it. Let us run and check if it is working fine. So for j, or should we, so we have to say int j since it is not declared in the scope. So running again. So we have to give an input. Let us give the input as 4. So it's a 4 cross 4 n queens problem. So this is our answer. So this is saying, so place a queen in this way, here, here, and here. So that is what you exactly got. So if you just wanna look at how this is function works, so let us trace this thing out. So this function checks for what is known as a column attack. So it will check. So let us assume. So let us assume that there will be no. So nothing is placed here. So let us assume there are already some queens placed like here, here, and let's like here. So now you want to place a queen here. So how would you check that it is not conflicting? So you have to in this row. So this is the row X. So in this row X, for every column Y, I have I have to check.